Alrighty, I think it's good going. Someone please shout at me if you can hear me. Just going to run a few checks first to make sure everything's working. Oh, something's working. I'm trying to run all of this off one screen, so trying to work out what you can see and what I can see are slightly different things. Anyway, welcome to this stream. The idea of this is basically loads of people have asked me how I model things in CAD, and instead of trying to explain it, it's probably just easier to show you. Or bore the socks off you, whatever. We'll see how this goes. No planning, I'm not a YouTuber or anything, so no real idea how we're going to go here. But yes, please can someone confirm whether you can hear me? Hello Gary, hello Becca, hello Alex. I think my internet is a little bit slow. I'm waiting for a response from someone, please. Video good, sound good, that'll do, thank you Alex. Alright, let's make a start. So, subject for today is an SER diagram 1328 4-plank coal wagon in 8, 9, 10 ton flavours and express or standard versions. I think I'm going to go for the standard version because it should fit the Allen Gibson 14mm Mansell wheels quite nicely. As far as I'm aware, they're the only sort of standard easily available Mansell wheels out there. I could 3D print some wheel sentence for something else, but well, that'll be effort, and as you're probably about to learn from this video, I'm not particularly into effort. So, these wagons were designed, it's a little bit difficult to work this out from the book I've got. So the drawings and the information I'm using are coming from an Illustrated History of Southern Wagons, Volume 3. And I'm literally taking dimensions straight from the book. So there are a few hundred of these wagons built from 1864. The design I'm working on was built from 1887 and designated the Express type because it had slightly larger wheels and slightly different buffers to the original type. So the book's got a couple of drawings to scale, to 4mm scale, and a couple of reference photographs, but I haven't got a whole lot to work on, so there may be the occasional inaccuracy. Let's see how the chat's going. Evening Killeen, good to see you. So, just as a slight aside before I get onto the wagon, I can't show you what I'd normally do with sort of diagrams and reference information for this one because it's already in a book, but for locomotives or other things, generally what I would do is something like this. So this is my data sheet for the LCDR second Sons class, which incidentally I'm still working on. I should start testing building that at some point when I've got a wheel order done. So I will typically have a scaled drawing, so I can literally just use a ruler and measure off this. It's much easier than trying to scale things and doing all the calculations in your head. I'll have some basic reference information. Usually I use a more reliable source than this, but that gives me some basic dimensions that I can make sure I've got the scaling right using. I will also tend to usually blow up the diagram nice and big so I can get all the details. Otherwise it's quite difficult to work out sometimes which line you're measuring from on a small diagram like that. So you can use the big diagram to work it out and then go back to using this for scale. And of course, all the all-important reference photos, usually as many as I can find. But of course, this being a particularly old class, there's not a whole lot available. So I will then usually print this out on both sides of a sheet of A4, double check it's to scale again, and then just use that for all my measurements. So let's see if I can get rid of that. There we go. Gary's looking through the book. Nice. Yeah, so Gary knows what I'm doing and presumably can error check things. So I'm modelling this in Fusion 360. Hold on a sec, having a drink break. Excuse me. Right. This is what Fusion 360 looks like. You have all your standard CAD modelling tools and things going on over here. They give you a little sidebar as well where you have the project and all the files that are in the project. As you can see, we've only got one and there's nothing in it at the moment. Use this to go back. The book's falling over. So most bits of CAD software will have some fairly similar sets of tools. So we have sketches, extrusions, revolutions, so on, patterns, and we have a whole load more down here. It just puts the common ones in a little thing. Some modifications, so rounds and shells are particularly useful ones to have. We have assembly, but that will come much later in the project, and we have construction for adding various planes and things like that. We might get into that later. So to kick off, basic process is sketch something, extrude that sketch, and then make the modifications you need to it afterwards. So I'm going to start with this plane here, zoom into somewhere in the middle, and I'm going to start with a center rectangle. This is my first top tip. Always start from the origin and always start with a center rectangle. So I'm modelling the floor first, so I can measure that up. That should be 56 millimeters by 31, I reckon. Let's just double check that. That would be just under 56 millimeters. Let's call that 55.75 by 31. So 31 by 55.75. I tend to work to what do you call it? I tend to work in 0.25 millimeter chunks, because under that you're not really going to notice it, and it's within the tolerance of 3D printing anyway, so it doesn't really matter a whole lot to me. So there we go, we have this. And now this is perfectly centered in my origin, so I can use the origin planes if I need to mirror anything, which is probably one of the most useful tools in your CAD arsenal. So that's that. Extrude, it automatically picks that sketch for me because it's the only one that exists. And let's see how thick that floor is. That floor is 1 millimeter thick. I have to make a decision at this point as to whether to go up or down. I think I'm going to go up. Okay, there we go. That's a good start. So we have our floor. Next part to make is, what should we go for? Should we go for the planking? I think we probably should. Okay, so Sorry, this is a bit slow. I'm making things up on the fly here. Let's have another center rectangle. Use the snap points to snap it to the existing. Let's just make that any old size. And of course, rule number 1 of CAD, no blue lines. Always get rid of your blue lines. You do that by dimensioning things. That will probably over-dimension it, yes it will. Okay. Second rule, don't over-dimension things. Let's pull that in. Set that dimension. Clicked on too many things there. Start again. And set that dimension as 1mm. So you can see when I set the dimensions, this rectangle inside is now fully constrained, so it can't move anywhere. The point of that being, if I go back and then change something later on, this is still fixed to this, so it can't move and sort of cause other issues in your diagram, which I used to have a lot of before I did this. And the other benefit of using a center rectangle here is this point is also fixed. So if you noticed when I put it in, it snapped to this point, which is why I only have to put in dimensions for 2 sides, because it's symmetrical around this point. I'm using 1mm as that's the, for large areas, that's the minimum thickness I'd like to get away with for CAD. So let's have that, extrude that, hasn't automatically picked it. So Fusion 360, you pick which section of the sketch you want to use. So I could use this one, or I could use this one. In this instance, I'm going to go for the outside, and let's measure that. That is 12mm. Let's drop that in. Give it a quick save. And time for another drink break. Killian says I'd do buffer beams next. You could. In this instance, I'm not. It all depends how you want to do it, really. Everyone does it their own way. This is not supposed to be an instructional, this is how you do it. This is just me making stuff up as I go along, really. I'm going to do the... Actually, I'm not going to do that. Let's cancel that. One of the annoying things about Fusion 360, if you start a sketch and then exit it immediately without drawing anything, it still creates the sketch, so you have to manually delete it afterwards. Let's have a little bit of a rethink. Actually, Killian, let's go with the buffer beams next, I think. I was planning to do the planking lines around the outside, but I think I want to have the corner posts in place before I do that. Otherwise I'm going to end up with cutouts behind the corner posts, and it's all going to make the model a little bit untidy. So, where am I going? Buffers in this model. I appreciate you don't have the book, so you can't see what I'm checking right now. Buffers, or buffer beams rather, are actually in line with the ends of the wagon, which is nice and helpful because it means I can use this side as sketch plane. Let's double check that dimension. There is 30.5, so slightly inset. So I'm going to start my rectangle not at the edge there. Doesn't matter what side you start from, but you can see this line is black because it's snapped to this line from where I started it. So dimension that as let's not dimension that, let's do it a different way. If I can delete this. Oh, come on, Fusion 360. Right. So I've just measured that buffer beam width as 30.5 millimeters. Which it does not like. 0.5. There we go. Now, what I should really be doing, and what I've started to do lately, is try and dimension everything from one datum point, which helps keep your accuracy a lot better, because you don't get tolerance stack up and things like that. So what you can do in Fusion 360 is set the major dimension that you've measured off the model, and instead of having to dimension this side and this side, you can just pick this, click on that dimension, it'll add it as a variable. Divide that by 2 because I'm running from the center point here, and it drops it in the right place. Benefit of this being a function is that now if I ever change this to something else, let's put it 15 just to prove the point, it changes this and keeps that in the center, which is a trick I wish I'd known a few years ago when I started this whole CAD thing. So depth of buffer beam is 3 millimeters. So let's drop that in there. That's that done. That's running from that plane. Started going this way. So I'm going to put that distance as -1. No, a bit thicker than that. -1.25. There we go. That'll do. So that's a buffer beam in. Let's leave it at that one only for now, and put the corner plates in. So going to use, let's set this right. So I started off this origin here. So if I use this plane, it's going to end up in the same kind of area. Now, another nice thing about Fusion 360 is that you start from an object and fish on the same object if it will let me, which it won't, so it might not work. One of the nice things is that you don't have to do a complete sketch. So on most CAD softwares you'd have to draw this line and this line as well. Fusion 360 is usually intelligent enough to pick up that you just want that bit. So let's see if this works. Let's put that in. That's 2 millimeters. 0.2 millimeters is about the smallest you'll reliably get out of a bit of CAD software. Not CAD software, what am I on about? It's about the most you'll reliably get out of a 3D printer. So that dimension there is, let's call that 3.25. And on the other side, let's call that 3. That's 3.25. That is 3. Let's finish that. And hopefully, yep, it's picking up that I just want that section. So again, it wants to start going down, so I'm going to give it the opposite direction. So one of the other things with extrusions is, so far what I've been doing is using the profile plane and setting the distance in millimeters. That's all fine and dandy, but if you want your model to be a little bit more dynamic, so if I ever change this height, the height of this corner plate is then going to be wrong. So what I now do in this instance is set this section here. I didn't want to do that. Ignore what I just said. I wanted to use this one, the to object, not start from object. Pick that surface. I'm going to add an offset of 0.2 millimeters. Hang on a second. Just going to look at the diagram again. So those corner plates are set slightly under the top. It's at minus 0.2 millimeters, and hopefully you can see here, if I let zoom in, which I won't, here, that's now set to that plane minus 0.2 millimeters, which is what we wanted. Make sure it's a join operation. Should do that automatically, but there we go. So we now have a corner. I think it's time for another drink break. So, next job is probably to make sure we have this corner plate going all the way around. Now, what I think I'm going to do is detail that up first. So, right. I've got a whole load of rivets to draw on that, although fortunately the riveting on the express type is much simpler than it is on the original 1864 design. So let's get riveting. Of course this live stream is not riveting, but hey, what do you want? It's facts, not entertainment. Right. You'll see I've dimensioned that rivet 0.4mm diameter by sort of default. I've found with 3D printing that's what reliably comes out. So any smaller than that and you won't really get much of a chance to see it. So that one is let's call that 0.5, that 0.5. There we go, again, getting rid of all the blue lines. And those are all, oh, please don't tell me they're not equally spaced. They are not equally spaced. Thank you, SER. Right. Okay, I'm going to have to do this several times. So extrude that. I'm aiming to make this a hemisphere, so half of the diameter. Fill it. 2 millimeters. There we go. One rivet. Now let's not make a pattern of that and start a new sketch. Normally what I would do here is make a pattern of those two features running up here, but because the rivets on this wagon aren't actually equally spaced, I can't do that easily. So there are 7 rivets running down the side of this. This bottom one is slightly oddly spaced, and there are 3 here equally spaced and 3 up here equally spaced. So I think I can get away with drawing another set in here. So I'll make that 0.4, that 0.4, that 5. So what I can do here is make that 2 millimeters, and that one 8.5 up to that. So you can see here again I'm trying to use a universal datum point to run all my measurements from. Otherwise, if I do a measurement from here to here and a measurement from here to here, there'll be a little bit of error in here and a little bit of error in here. So I'll get twice as much error as I have if I'd just done that. Killian is commenting on the size of the rivets. What size do you run to then, Killian? I've done some experiments with various sizes and I found anything below 0.4 millimeters, you'll sort of get a maybe 70–80% success rate. But 0.4 millimeters seems to get me much closer to 100% success rate for that. So that's what I've settled on. Let's do that and that. Again, 0.2, same process. That and that. 2. Right. First use of a pattern. In Fusion 360 you have a few options. You can pattern a face, a body, a feature or a component. There's only one component and that's the whole thing at the moment, so we can't use that. Faces just copy the face. Bodies copies one of the things you've got in here, but again I've only got one at the moment. But what I'm using here is features, so I can select things from the timeline down here. And I want to select those two rivets, which were that extrusion and that round. We're going to pick this edge to use as a dimension. We want 3, that happens to work. And the distance between those is, I think, 4 millimeters. I'm just going to check that. Let's have a look. That is 2. That was 4 millimeters. That was 4 millimeters. Perfect. So what? 4 and now 3 parts. 1, 2, 3 there. 1, 2, 2 there. I think. Let's see if this is going to work. Yes, perfect. So that saved me drawing 4 rivets. I've drawn 3 and I've ended up with 7. So much easier. And you can see how they're not equally spaced. So this spacing is different to this spacing and this spacing. Yeah, see, I never like to make anything easy, do they? I'm guessing. So I have to do a very similar operation here as well. So what I can probably do is put in a mirror plane on this 45 degrees here. Yeah. So another comment from Killian there on the rivet size, 0.32 to 0.38 millimeters. Yeah, I've never really designed much to more than one decimal place, so usually I'll try and get away on major dimensions. I'll try and get away with the nearest 0.25, the nearest quarter of a millimeter. So that's usually good enough for me. Sometimes on very small details like this, I'll go to the nearest 0.1 millimeter. But below that, really no one's going to notice. Shh, don't tell anyone, but no one's realistically going to notice that. So that's just what I stick to, really. So I've never actually done this before, so let's see if I can make it work. We have a plane at an angle to, I think it's going to want me to pick this line here. No, it isn't. Let's pick that line there. 45 degrees. Has it done? I said 45, not 15. Come on, computer. 45, that's the wrong way, so let's call that 25. Check. And then we use the other favourite tool. I'm going to pick features again, but sometimes it doesn't like copying rounds as a feature. I guess we'll find out. So let's have that, and that in this plane. These I find adjust and optimize. I don't really know what the difference between those two is. Identical just as it sounds, makes things identical. I tend to usually leave it on adjust, but sometimes that can take up a bit too much processing power, so if it does, you can drop it down to identical and you usually get pretty much the same result. So let's see if it does this, which it does. Perfect. And I'm just going to turn that plane off. So construction here is all the additional planes you've added. So I've added that one, I've just turned it off, just to avoid distraction really. So that's that done. Let's get the mirror tool back out. Features, which it already is. That, if it'll let me select it, which it won't. Here's that feature. I'll just try and remember which ones of these are on this section. So let's have all of those. Mirror that. Again, this is why we use a center rectangle, because I could just do this without creating any extra planes. Let's have it adjust, see if my computer will run it, which it will. And there we go. Same thing, opposite corner. So let's use that again. Pick that, and the mirror we've just done. And stick them in that plane. And that has also worked rather nicely. So there we go, we have 4 corners and we've only had to draw 1. Let's have a quick catch up with the comments. Gary is working out which version he is from the rivets. Yes, Gary, it is the 1887 Express type. Wow, that technically makes you a rivet counter, doesn't it really? Yes, I'm doing the Express type because I can just buy the Allen Gibson wheels for it. That's basically the only reason. Yeah, I'm not sure if anyone does sort of other sizes of Mansell wheels. So I've been thinking about designing some 3D printed centers to swap into other wheels, but if anyone knows of any sizes of Mansell wheels other than 14mm, do let me know. Because quite a few wagons in this book I'd like to have a crack at, and yeah. Oh well. Have a drink break. Right. Now I do the planking. So the way I always used to do this was to use not a pattern, a path feature. So somewhere in here, a swept feature, sorry. So what you do is you draw your profile, draw a path you want to follow, extrude that. So I draw a profile sort of in this sort of plane on the end of the corner plate here, and then draw a sketch around the outside here and have it profile the planks all the way around. I'm going to take a slightly different approach this time because it's traditionally been quite difficult to draw it like that. So what I'm going to try this time is drawing it in this plane here. Revolve that slightly off center. I'm not using a mouse for any of this modelling, by the way. I'm just using sort of touchpad and touch screen. It's often nice to have a mouse, but I've grown used to not using it, so that's just the way I model. So let's put in a line. Again, it snaps. Do you see the X there? It snaps to that point. Let's draw a quick triangle. Like that. Use the equal tool to make it an equilateral triangle. Set one of the dimensions. So again, I've said 0.2 millimeters is about the biggest you can get away with. So let's make that 0.2. And dimension from that point there to that point there. So I'm going to measure that top plank distance. So the planks on this are all about 3 millimeters. Yeah, let's call that 3 millimeters. So that will be our top plank. You know what, I'm not going to draw all these individually. Let's just do one. So that's the top plank. Let's extrude that. This is one of the hard parts. It's allowing me to pick that plane. So what I sometimes have to do is pick something else on the same plane that I want, and then it'll let me pick that. Otherwise it just wants to try and pick this side here. Work in the system, but there you go. So I'll pick that, then I pick that, then I unpick that, it'll let me pick that, if that makes sense. So spin that around. Another nice thing about Fusion 360 is if you've got something and you click on a different plane, it'll assume you want to extrude it to that plane, which I do. And it's also automatically assumed that I want to cut, which in this instance I do. And it's assumed distance, which actually I'm going to change that to a 2 object, because if I ever change anything like this, if I change any of the dimensions, so if I change the length of those corner plates, for example, that distance would have stayed as a dumb distance essentially. Whereas if I do this, it'll update with the model. Let's do that. Do I want to mirror that? No, not yet. I'll do the interior planking later, because that has to go right up to the corners, not just up to this point here. Right, time for the pattern tool again. Let's have that feature. Let's pick a line in the right direction. There are 4 of these, and they are all 3 millimeters apart. If my maths will let me work, that'd be 8, not 8 millimeters. What am I on about? That's 4 of them. Like that. There we go, we now have some planking. Just going to double check something. I might have got my measurements slightly wrong. That's now 1.9 millimeters. So that means my original measurement of 3 millimeters for planks was wrong. So there are 4 of them. That distance there is 12 mil. That will be me being a little bit stupid. So that should be 9 millimeters. That's more like it. So let's check that. 2.8, close enough, bearing we've got 0.1 and 0.1 missing from there for the planking. So there we go. That looks alright. Let's have another drink break. Catch up on the chat. So Killian says this is immensely satisfying. Not really sure what to say about that. Maybe you should raise your standards of entertainment a little bit. I suppose it is better if someone else is doing the work. So, actually, let's hold off on that mirror for now. Do the same thing on this end. It will let me pick the plane I want, which is that one. Do that, start a line, do random dimensions, equal tool. Oh, something's gone wrong there. No, don't do that. What did you equal to? That's an odd thing. Let's get rid of that. It's picking that line, okay. Don't pick that line. What have I done? That. 90 degrees, that'd be right. I don't want that line. Stop picking that line. Right. That's it. Right. Not doing very well tonight. Picked the wrong tool a few times. Right. Start again. Do it properly this time. Start line. Let's draw something to there, something to there. To join those two lines up again. Equal to that line. That line. Just up hit. So it's probably quite hard to see this, but these blue lines, this little thing there. So it's automatically assumed that I want a 90-degree corner there, but I don't, because this is an equilateral triangle. So let's make that and that equal. And what are you doing? That equal. What am I doing wrong here? Let's redo that. Redo that. This is one of my frustrations with this bit of software. It adds so many constraints in by default. Is that collinear or is that an equal? That's an equal, isn't it? Let's delete that and try again. Let's make that equal to that. That is not one to solve. Let's drag it into somewhere it might be able to solve. Unselect that, equal that and that, there we go. Finally, 1.2 millimeters and 3 millimeters. There you go. It's not always plain sailing, but what can you hope for, really? Start from the profile plane. Let's set it to an object. Spin that around. Pick that plane. There we go, job done. And I'm going to go back and delete that, because what I should have done is pick that and that. Do it all in one go. Save myself an extra bit of work. -9 to get it to go in the opposite direction. 4 of them. There we go. So if I look at the diagram, you might expect there to be another plank line down here where the buffer beam joins the floor, but in fact looking at the diagram there isn't. So I'm not really sure what to do about that. Let's leave that as it is. And just over. Right. Next job. These wagons had a D end. So, oi, Gary Bot, what are you doing? Right. Yes, D ends. Let's do that. Pick this plane. Create an arc. Let's call it a 3-point arc. Make sure it's snapping to the right points. So I want that point. I want that point. And I want somewhere in the middle. Now, one of the more difficult things when doing things like this and locomotive roofs and things like that you haven't really got a radius or a reference point for. So how do we dimension this? Well, I'm going to draw another line from there up to there. It's already got a reference point at the end. So I've got a line now that I can actually measure on the drawing, which is, so let's try to find the line. Where did I start that from? Oh, the origin. It's down there. So I'm going to call that 15.75 mil, I reckon. So dimension tool 1.75. I'll look back at the diagram, that looks about right. So the normal way, sorry I should have explained first, the normal way you would dimension a cylindrical object is by drawing a circle and giving it a radius and a reference point to the centre of that circle. But here, we've got no reference point for that centre of the circle, it's down here somewhere. So doing it like this, giving it another known reference point and 2 start points, makes it much easier to get a sort of accurate dimension. So let's finish that, wait for my extrusion tool to come back, pick that and that. I'll put a line in the middle so it's split it into 2 now, but it doesn't really matter. And pick this side here, it automatically changes it to a join because it realises there's no material to cut there. Does it the right dimension, and there we go. Job done. I need to add another plank line to this point here, just up at the top. Actually I don't, do I? That's annoying, I've done that planking right at the end. Rightio, time to replank. So let's go back and edit that feature. Let's unselect that. So that's changed that feature just to be that side. This side now has a different pattern, annoyingly. Which sketch was that? Was that this one? I think that was this one. So I want to edit that sketch. So the end planking also has, well, it's a little bit different here. Let's try and work it out. So that is the base there, so I want that to be 12mm above the base, not 3mm from the top. Let's pick that, and again working from my universal datum, 12, that wants to be right up there. Okay. And at this point, it rebuilds all the stuff I've done afterwards, so it's still got the cut in there, which is nice. Let's start another pattern. That drops down by, let's call that 8.5mm, and there are 4 of them. So select the feature, which is that one. Let's pick direction. Can I pick that? I can pick that. Excellent. What did I say? Minus 8.5, and there are 4 of them. 8.5. Is that right? No, it's not. Well, it sort of is. One, two, three, 4. That is right. Okay. So what was confusing me is that there was an extra plank, of course, for this one here, but it's at a different spacing. So let's pick that again. Let's pick that again. And that spacing is 10mm. Minus 10 because it's in the opposite direction, and there are 2 this time. To add that plank in at the bottom, which I think might need to go a little bit lower. No, it doesn't. Okay. Well, that's right according to the diagram, so it will have to do. So Gary has said at some indeterminate point in the past that the bottom of the bottom plank should line up. Don't think the bottom of the bottom plank should line up. Okay, I think that's the error I've just found. There we go, another comment saying looks right for me. Good. Good. Okay, that's that side done, that end done. So, time to get the mirror tool out again. Wherever it's gone, down there. Features, let's have that one. What was that feature? Can't remember. That's that one. Don't want to mirror that one because that's in a different plane. That one and that one in that plane. You can see it puts a ghost image of where it's going to go, which is good because that's exactly what I want. Yep. And let's pick that one, that one, and that one. What I'm also going to do is pick that end and this buffer beam here. Where did we draw that? Is that this one? No. That one? Or that one? That one, I think. In that plane there. And there we go. It's starting to look like we have a wagon on our hands. Now, what do I do next? So the next major things I think for me are the interior floor planking, the interior walls planking, which is going to be a pain, and buffer beams, which is also going to be a pain, but I can use the mirror tool a lot here to swap sides and ends. So actually we only have to do 1/4 of the buffer beam essentially. Tell you what, Let's do that interior planking first. It's a pain, but we shall get it out of the way. So, same trick as before, only this time we don't actually have a diagram. Yeah, it's trying to snap to lots of points here, so I'm picking somewhere to draw the initial lines that it doesn't do that, so then I can dimension it where I want to, and hopefully it saves us having the trouble we had last time on the end planking. So let's make those all equal. That's gone the wrong way. Don't do that. Drag that point out, and then equalise those. And it has become absolutely ridiculously tiny. Fusion 360, why do you do these things to me? Let's undo stuff until that does that. There we go. Deselect everything, equals again. Why are you doing this? Let's pull that in. You know what? I'm going to save myself the faff and deselect everything again. Just measure that. 1.2. We'll do the old fashioned way. 1.2. There we go. Right. I didn't mean to finish that sketch. Let's go back into that edit. Dimension again. I'm going to pick that end. Now the interior planking is not on the diagram, so I'm going to follow what's going on here on the. Not much use me pointing at things, is it? Because you can't see that. I'm going to follow the same kind of thing that's going on the outside, because that was nice and easy to draw, basically. So let's do that. Finish that sketch, and here we're going to do my old trick of doing a swept path, because I'm going to do the same blanking pattern on the sides and the ends, and that's probably not realistic, but really not many people are going to notice that, and it's going to take me absolutely ages to draw it properly. And plus it's on the inside of the wagon, so by the time you put a load in there, you're never going to see that. So, right. Extrusion tool, sweep. I don't want to sweep that. If this, so again, same kind of issue we had before. This sketch is getting in the way of me selecting that. So I'm going to go in there, turn it off, pick that, then pick the profile I actually want, then unpick that, turn this sketch back on, zoom out a little bit, and use that as the path. It is automatically suggested I want to cut, which I do. Perpendicular, so you want to pick this one, because then it changes, so the cut is in the opposite direction on this wall, so it is on this wall. If you put it in parallel, it would try and cut that way around all the way and it wouldn't work. But that is useful for other applications. So we're going to put perpendicular, don't want any of that, want to go the full length of the path, cut, okay. Give my old poor laptop some time to cope. There we go. Again, just pattern it. So let's use the origin as dimension. Always use the origin for stuff if you can. It just helps when you go back to edit things, things don't get broken, all that kind of faff. There are 4 of them, and we'll go down by 9mm, like that. And nicely, as it should, this lines up perfectly with our floor, which is good because that's what this bottom planking here is. So, tell you what, I'm actually going to go back and take that out. So we want 3 in there, and we want 9 times 3/4. So let's go 9. I can't be bothered to do the maths for this, so I'm just going to make Fusion 360 do it. 9 times 3 over 4, like that. Which looks a little bit wrong. Why did that look wrong? Someone tell me what I've done wrong with my maths here. I don't know what was doing. Oh, that 2/3. So I've got an engineering degree, but it doesn't mean I can do basic maths. So let's have a look. Ooh, something's kicked off in the chat. So Gary is suggesting to have a look on the next page. And indeed, there is an extra line at the bottom on that particular wagon. However, that doesn't quite look the same as the express type diagram. Several of these were built in several batches, and I'm guessing there are detailed differences between them. So the one in the diagram has a slightly different coupling of mounts and safety chains, which the East Kent one in the picture doesn't have. Not quite sure what to go with there. I think I'm going to stick with the drawing. Yeah, let's stick with the drawing. Always detailed differences in various batches in production, things like that, so slight errors don't bother me too much in that regard. Now, where to next? I think I'm going to have to just face it and tackle that buffer beam. So, this is one of the areas where your reference photos really come into their own. Let's have a look. So there's also a close-up of a fairly similar buffer diagram on the previous page, for those keeping up with the book. Plates, let's say plate 28, I think, has a very similar style of buffer by the looks of things. Which is probably the closest up photo I'm going to get. So we have a wooden mounting block, circular, and then the buffer coming off that with this complicated sort of ribbed circular thing going on. That is going to be a right pain to draw, but might as well bite the bullet and get on with it. So let's make a start with those pads. So again, this is the. Everyone thinks CAD is really complicated. It's not. It's the same 3 or 4 processes over and over again. Sketch a thing, extrude a thing. That's about it, really. Lots and lots of prisms. That's all you have to worry about. So let's call that 3.5 mil diameter. And I reckon that is 1 millimeter down from the origin. Over there to there, nice and straight, 1 millimeter, which it is, but over the bottom slightly, so I'm suggesting that is slightly wrong. It's a little bit more than 1, isn't it? that is about where it's supposed to go. That might be Y. Let's call that distance there should be that distance there, which was 3 meters, I think. Not 302, which is 1.5, which is what it was anyway. Well done, Tom. Classic expert CAD design work there. And the look shut up. Sorry about that racket that's just started up. That's the fan heater in the corner going up. I might have to turn that off. It'll freeze. Buffer center distance is 22.5 millimeters, so half of that is that. Where's that heater switch gone? Bother, give me a second. There we go, you might be able to hear me properly. Well, you may hear me without my heater on. So let's finish that sketch, extrude that and that by, let's call it 0.75 mil, like that. So that's that done. Can I use my normal buffer creation trick here? I'm going to have to give it a go on that. Right. Crafty buffer creation trick number 1. Let's construct an offset plane from the midpoint by the distance of your buffer center distance, which is 22.502. The construction planes I have turned off. Let's turn them on and turn them off individually. There it is. So let's pick that for a new sketch. And then draw the buffer outline, which is sort of something. Something a little like this. So a quick look at that picture again. So it goes back up. I'm not worrying at all about the dimensions at the moment. Like that. Back up. Back over and joins up like that. Yes. Yeah, that looks about right. So let's start dimensioning that. First tool, collinear, means making a line on the same place, which is not going to let me do because that is not a square line, it's a circular line, so it's in lots of different planes at once. That's annoying, but if I remember rightly, that dimension is 0.75. Yes, it is. Good. That hopefully will line up with the center of this, which lines up with the center of the buffer beam, and handily it's already in the right place. That line there I want to be 3 point something. It's fractionally less than that, so let's call it 3.25. Not 3.25, 3.25 over 2. That I just want to be thin, so let's call that 0.5, which it is. That distance there on the buffer shank is fairly small. That's 1 millimeter, so that's 2. So here, when I'm halving things, I like to actually halve them in the software, because then if I click on that again, it shows me what I've done, so I can tell where I've got that measurement from. You see what I mean? That distance there is... This is where it gets pretty difficult to read stuff off the drawing, because there's so many lines close together that you can't really tell what you're measuring to and from. That distance there is 3 millimeters. Let's mess that up. So let's try and drag that back out of the way. That I'm going to arbitrarily call 0.5 for reasons that you'll see in a minute. That's going to be 0.7502. That is going to be, so for thin walls like this, the thinnest I like to go to is 0.75, so that will just have to be 0.75. And that distance there is 6 millimeters, I think. Yeah, that's cool, that's 6. Buffer diameter is 4 millimeters. That distance there, arbitrarily, I'm going to call 0.25 again for reasons we'll find out in a minute. And now we have all black lines, so we can finish that sketch. Here we go. The other useful tool, the revolve tool. It's already picked that for reasons best known to itself, I guess. This is our axis, 360 degrees, done. We have a very skinny looking buffer, which on reflection, I'm going to go back and make a little bit more wrong. So again, another annoyance of 3D printing. Things are very weak, it's very brittle. So I'm just going to beef this up a little bit. Makes it more likely to print, and your model will be wrong by 0.25 millimeter. And if you're noticing that, then frankly you're going to have to scratch build something. So the reason I picked 0.25 for this distance here and 0.25 for that distance there is just because I'm going to round it by that much. 2.5, not 2. Then we get a nice hemisphere over the top there. That one is rounded, that one isn't. Just checking back with the drawing again. Yep, that all looks good. And putting the round on here as well just makes it look a bit softer, a bit more real. I don't really know how to describe that, but that's what it does. There we go. So I'm just going to go back and edit that sketch again because I've just noticed in the photo that looks like it should be a bit thinner. So let's do that. Again, I use my universal datum to measure this distance here from the end. So you notice the whole thing didn't move in by 0.25, it's just that moved in. Right. Now we get to the hard part. So those of you who got the book should be able to see that there is a sort of complicated rib arrangement going from here to here. So they're at 45 degrees and they have a rather nasty curve in the middle as well, which is not going to be fun to draw, frankly. So, I think we might have to call on our old friend the angled plane again. This fancy new skill I've just learnt. it's not going to let me pick a line, is it? Let's see if we've got another sort of plane we can use. Tangent, point, tangent to face, path. I don't want an axis, I don't want a point. I can't really do it through an axis. Can't really do it through two edges. This is more of a challenge than I thought. So, plane angle. Let me pick the axis there. Or, So, Fusion 360, after you sketch something and extrude something using that sketch, it turns that sketch off, so it's not blocking your view. However, you can go and turn it back on, at which point it should let me select that line there, which is through the center point to exactly what I needed. So we've got that to 40 degrees. Let's go minus 45 degrees. There we go, job done. Turn sketch back off so I can get in the way. Create sketch in that plane. Right. And you can see our plane has a new origin there, which is going to come in useful, I suspect. Right. Leaf buffers certainly are a challenge. So we've got sort of an arc type thing. I'm going to use a 3-point arc for this. Pick that point there. Does it go right up to the edges? Yes, it does. I want that point there, but it won't let me select, so I'm just going to pick that for now. And let's put it in, say, there-ish. Let's see if I can make that sit on there. I can. Good. Can I make that sit on the end there? No, I can't. Less good. We might have to do this one the old-fashioned way. So let's pick that and that. 2.5, because we know that's in the middle. Pick the origin, which is that should be 1. That dimension there should be, what was it? I can't remember. 3.25, wasn't it? 3.25/2, yes it was. Spot on. Right. Let's do some more lines. Not in that way. And that to there, and that to there, and that to there. Dimension that to there. That 0.25 doesn't really matter because it's inside the shape anyway. That is still blue. Why is that still blue? Do I need to set a radius? 3.2. Let's go for 5. 6. 0.75. Yeah, that looks about right. I'm just going to drop that a little bit as well. Let's call that 0.95. 0.65, 0.95 please. Thank you fingers for letting me type. And let's drop that a tad as well. Rough dimension is 3.25, so let's have 3.25 minus 0.1. Nope. Minus 0.2. There we go. Hopefully the reason I'm doing this should come. Let's pick that already. Now, because my plane is in the centre now, I want to pick both sides. I want to do it symmetrically. And I want that distance to be, let's see what it does here, 0.75. That looks way too big. So I think it's probably doing 0.75 each side, in which case I'm doing 0.75 over 2. That still looks a little bit big to me, so I'm going to go for 0.5 over 2 and just sort of hope it prints. It's automatically cutting because there's a bit of overlap, so I'm going to have to change that manually to a join. You know what? That's not too awful. Let's just make that a bit less dramatic. About 4. 4.5. Yep, that will do. Yeah, and the reason I pulled this in slightly was so that that square edge didn't start overlapping this rounded edge. And it hasn't here either, which is excellent. Good. Thanks for the compliments on the buffers, Keen. Sorry. That should get even better in a sec, since I've added some more stuff. So, judging by the photo, these buffers look like they're held on with rather large bolts, or nuts rather. So, we are going to pick a circumscribed, that nearly went wrong, polygon, 6 sides by default, which is what I want, and diameter. If I want a rivet to come out at 0.4mm, I want this to come out at 0.4mm, so that half distance there is going to be 2. There we go, let's set that distance as something in the middle, so let's call that 1.25. Yeah, it looks a little bit higher on the drawing in the middle, so that's actually probably about right. That distance there, I want to be nothing, which it looks like it is, but just to make sure, oh, it's not going to come on. I'm going to run that. See, it's not inline, is it? So I have to set that perpendicular to something. Let's select that. Good. There we go. I'm going to ignore the no blue lines rule on this setting because it would mean I have to make all of these equal. For some reason, it doesn't automatically equal polygons, and frankly, I can't be bothered to fix that. So let's put that out by 1.25. That looks about right. Good. Pattern. Here's the other type, circular pattern. I want to count the features, that one and that one. I'll use the buffer I've already made as the axis. That's 4 of them because there are 4 of them. Full axis, that's good. Suppress, I don't know what that does. And there we go. We now have a rather complicated buffer. It looks kind of heavy-handed, doesn't it really? But bear in mind this is several times the actual size. And by the time you shrink this down to 4mm scale, on my screen at least, it will be, let's have a look, about 70mm long, which is about that. So your screen size will differ from mine, but that is pretty tiny. to be honest. So I think we'll probably get away with it being a little bit heavy-handed. And again, it overlaps the bottom, just like on the prototype. Good, that's all nice and fine and dandy. What else should we put in there? So it looks like there is a small rivet in each corner. So let's just pop that in quick. Use a circle. So I'm using a few keyboard shortcuts in Fusion 360. C is the shortcut for circle. D is the shortcut for dimension. And just using the number pad to chuck stuff in. That's a little bit further away than I thought it was. Let's measure that. Let's not measure it with the inches side of the ruler. That's 1, not 0.75. Do extrude that, 0.2 again, round it, 2 again. Okay, let's mirror that, I think. Or that whole lot, rather. So I'll start with the buffer pad, the revolution, the round, that and that, pattern, and that and that. Let's mirror all of that along in that centre plane there. Hope it works, which it does. Good. Now before I swap that to the other end, I'm going to put the coupling hook hole and mounting point in here as well. So let's do the mounting point first. Okay, so it's a sort of strangely shaped hexagon thing, this one. So I'm just going to draw this out manually. Do that. Always use the constraints tools up here before you start using dimensions. Make all of those equal. I didn't mean hexagon, did I? That's fine. Let's get rid of that. Start with another line. What I of course meant was octagon, because maths is hard. That's equal to that, that's equal to that, that's equal to that, that's equal to that, and that's equal to that. Good. Shove some dimensions on here. Total width is 5mm. From that end is 1mm, so that total thing is 2mm. So that should be 5. Let's cocked everything up. Let's pick that. Ooh, it does like being weird, this, doesn't it? Windy gun or weirdy shapey. Dimension. That to that centre point is going to be this dimension of 2. That there is 2mm. Wow, this is funky. That there is also 2mm. That there is And let's see if I can fix this mess. Okay, so that's not letting me drag, so let's get rid of that. Still not letting me drag, so let's go back to where we were before. That all went pear-shaped. Let's make that look a bit more respectable. Put a line in here. Yeah, let me do a construction line there, won't it? Okay. Snap onto that point there. Get out of that. And let's make that parallel to this. Now hopefully everything should stay in line. Then I make that 1mm. That with constraint sketch. What did I put in there that's constrained? That dimension there is already there. 2mm, there we go, looks more like it. So I'm not going to use that dimension, I'm going to use this one here. Really, let me select that. No, you won't. Why are you doing this? That dimension is approximately 0.5mm. There we go. No blue lines. Good job. Extrude that. 1.25. Start a new sketch. Create a couple of rivets. My laptop is struggling to keep up at the moment, as am I. So, sorry, I'm checking the chat. I haven't checked that for a while. Javier's turned up. Hello, Javier. And Matt asks, can you save that as a separate file to use on other wagons? I assume you mean the buffers by that, Matt. You can. What I would probably do is just save it. What I would probably do is be a massive hack. Save this whole thing, cut everything else out, and just save the version as the buffer itself. I could also alternatively have made this as an assembly, so just have made the main body and made the buffer as a completely separate file and then assemble the whole thing afterwards. That's probably what I would have done in the old bit of CAD software I used, because it had some really good assembly tools. This one doesn't, so I find it much easier to build it in place. So let's check that dimension, which is 4mm, and it's in the centre, which is, so I want to make that, so that point there, 5, which it is, and that to that point there, I want to make that 2. Job done. Extrude that by 0.2, fillet, 0.2. Finally, cut the coupling hook hole. I'm going to use dimensions that I happen to know work from other projects, so I'm going to call that 1.1.75. I'm going to call that 1. Again, move it to the middle. So I want that dimension over 2. And I want, because I know that rivet's in the centre, so I want that dimension over 2. There we go. Extrude that to this surface here, cut all the way through, there we go. And now I think that is one in done. So, those walls are looking a little bit thin. So I'm just going to edit that to 1.5mm. I think that those are the dimensions I used on previous wagons. I'm not going to go and check right now. So let's keep going. Finally, I think I'm going to mirror that lot, which started way back when with buffers. That one there. Revolve around, extrude, extrude, and extrude round, mirror, extrude, extrude round, extrude. All of that lot. Here, this is where my computer may have a slight breakdown. And let's see if it does that. Which it has. Well done, computer. Good job. So, oh, I haven't done the floor planking. Probably should have done that earlier. Again, I've selected the wrong sketch plane, and there is no way to change it. Keep using the equal tool because it's just so lovely. Stick that in there. Internal plank dimensions. I don't know where I can get that information from. This book has it for some wagons, but not all. Let's see if I can find it. No, I can't. Well, if anyone does know internal plan dimensions, do let me know. No information. Well, in that case, I'll just have to make it up. So, where can we put that? It's currently 4mm. What did I make? The thing. Let's call it 2mm for now. And then interrogate that edge. That edge is 53.75mm. So, what does that nicely divide by as a whole neat number? Just going to pull up the calculator window, which I don't think will come up on the stream. So pick that, it was 53.75, so let's divide it by something until we get to about 2mm. So I reckon that is about 27 planks internally. So let's have 53.75 divided by 27. That means each plank has to be 1.9. Well, each plank has to be 1.99mm long. Let's just call it 2. Okay, that means I've accidentally put that in the right place. Extrude, pick that, unpick that. I forgot to dimension that, didn't I? Oh well, I'll do that after I've done this. From object to object. I believe my computer will stop crashing. That object, cut, good job. Edit that sketch. Where's it gone? There it is. Dimension, see, I left some blue lines in. Not good enough, Tom. So, 2, there we go. That's what we wanted. Pattern, again, let's have that feature in this direction, and it's 2 mil from the end. Let's change that to a spacing distance of 2 millimeters, quantity of 27, I think we said. -2. Thank you. Enter. Job done. Some nice internal floor planking there. And I think that's probably a reasonable time to end this stream, so that you can all get on with your lives and do more entertaining things. So my plan for this is basically just to keep doing this. I'm not sure, I think I'll probably do another one at the same time next week, and essentially run through the entire project is my idea. So we've got a good basic outline of the wagon now. So I've got a load of strapping and ironwork and stuff to draw on the main body. We've then got the chassis and wheel set to do. And then hopefully after that I'll also be live streaming print setup. So I'll go into my slicing software, we'll have a look through that. I'll set it up to actually print it, hopefully. Well, I'm not live streaming the whole print because that would be 10 hours or something ridiculous, but I'll live stream the setup at least. And then the build of the actual wagon. So we'll have something from a basic idea, from a sketch, all the way through to a finished wagon that I can run on my layout, which doesn't exist yet, but I can run on my test track. So yes, we'll leave it there for now. Let's save again. Another nice feature of Fusion 360, you see it's put version numbers in here. So if I go to my data panel, if something goes wrong or your file corrupts or something, I've got all the old versions in here that I can use, that I can roll back to if something goes wrong. So that's that. Thanks for tuning in, guys. I hope it was useful, if perhaps not the most riveting entertainment you can have on a Saturday night. So yeah, thanks for tuning in. Hopefully I'll see you next time. Cheers, guys.